science viewers, in our previous video already we discussed activity 9 and activity 10. Children, what we understood about that? According to activity 9, we understood that don't mix water to acids or bases. Always add acids or bases only to water. Okay? And what is meant by exothermic reaction? And next, to activity 10, what we understood? Yes, acids and bases are of two types. They are strong acid, weak acid, strong base and weak base. Which acids are called as strong acids and which acids are called as weak acids? The acids which produces more H plus ions in an aqueous solution are called as strong acids, and the acids which produces less number of H plus ions in an aqueous solution are called as weak acids. Similarly, in case of bases also, the bases which produces more number of OH minus ions in an aqueous solution are called as strong bases, and the bases which releases less number of OH minus ions in an aqueous solution are called as weak bases. Okay. So, this information already we discussed in our previous video. Okay children, let us move on to understand the next topic, that is universal indicators. Children, in acids, bases and salts part 2 already I explained indicators. Children, can you tell how many types of indicators are there? According to acids, bases and salts, yes, 4 types of indicators are there. What are they? Natural indicators, synthetic indicators, olfactory indicators and universal indicators. In that video already I explained what are natural indicators and synthetic indicators and olfactory indicators and their properties also. And in this video we are going to discuss about what is universal indicators. Okay, children, what is mean by universal indicator? Universal indicator is a mixture of several indicators. Universal indicator is a mixture of several indicators. The main indicators used to prepare the universal indicator are methyl orange, methyl red, phenolphthalein, thymol blue, etc. And next, children, what are the uses of universal indicator? Universal indicators are used to know the strength of acids or bases, and it shows different colors at different concentrations of hydrogen ions in an aqueous solution. Here, hydrogen ions means H plus ions. The example for this universal indicator is pH scale. Children, what is meant by pH scale? A scale which is used for measuring the concentration of hydrogen ions in a solution is called as pH scale, which means pH scale is used to measure how acidic or basic a substance is. For example, take hydrochloric acid solution and acetic acid solution. Children, take pH paper and dip the pH paper in HCl solution, means hydrochloric solution. It turns into red color. And take one more pH paper and dip the pH paper into acetic acid solution. So it turns into light yellow color. Here both are acids and here we have taken only pH paper only. But why the color changed in these two cases? Because HCl produces more H plus ions in aqueous solution and acetic acid produces less H plus ions in aqueous solution. So HCl solution contains more H3O plus ions, means the concentration of hydronium ions means H3O plus. The concentration of hydronium ions is more in hydrochloric acid solution and less in acetic acid solution. This is the reason for getting different colors. And this pH scale was introduced by Sorensen. The P in pH stands for potens. Here the letter P means potens. In German, potens means power. Here the pH scale changes it into different colors depending on the power of the ions. Okay. Next, children, look this picture. This is called as pH scale. The pH scale ranges from 0 to 14. A pH of 7 is neutral. A pH of less than 7 is acidic. And a pH more than 7 is basic. The pH value increases from 7 to 14. It represents a decrease in H3O plus ions, means hydronium ion concentration, or an increase in OH minus ion, means hydroxide ion concentration in the solution. Next, look the table. Children, here they have given some solutions. They are acids, bases and neutral solutions also. By using pH paper, you test these solutions and write down the color of the pH, what it gets when we dip the pH paper into the solutions. Next, on the basis of that color, you should write down the approximate pH value. And next, on the basis of this pH value, write down the nature of the substance. Children, look here. The first solution is hydrochloric acid. When we dip the pH paper in hydrochloric acid solution, the paper turns into red color, which means approximately the pH value of the HCl is 1. The pH value of the HCl is less than 7. So, the nature of the substance is acidic. Next, look the seventh solution, which is sodium hydroxide, NaOH. When we dip the pH paper in NaOH solution, the paper turns into purple color. So, approximately the pH value is 40. If a substance contains pH value more than 7, we call that substance as basic. So, the nature of the substance is basic. Similarly, look the eighth solution, distilled water. When we dip the pH scale in distilled water, the pH paper turns into green color. So, approximately the pH value is 7. The substances which maintains pH value as, we call that substances as neutral. pH value as 7. Children, the substances which contains the pH value from 0 to 3 are called as strong acids. Next, the substances which contains the pH value from 4 to below 7 are called as weak acids. The substances which maintains the pH value as 7, we call that substances as neutral, means neither acidic nor basic. The substances which contains the pH value from above 7 to 10 are called as weak alkalis, and the substances which contains the pH value from 11 to 14 are called as strong alkalis. Children, next, the pH value is logarithmic, and as a result, each whole pH values below 7 is 10 times more acidic than the next higher value. For example, the pH of 4 is 10 times more acidic than pH 5 and 100 times more acidic than pH 6. The same holds for pH values above 7, each of which is 10 times more alkali than the next lower whole values. Example, the pH 10 is 10 times more alkaline than pH 9 and 100 times more alkaline than pH 8. Children, next, the pH is defined as the negative logarithm of the hydrogen ion concentration. The equation is pH is equal to minus log of H plus. Similarly, POH is equal to minus log of OH minus. The purpose of the negative sign in the log definition is to give a positive pH value. Children, The following statements are made about the pH scale. Increasing pH means the H plus ions are decreasing. Decreasing pH means the H plus ions are increasing. By these two statements, we understood that H plus ion concentration and pH relate inversely. Means here the pH value increases, the hydrogen ions concentration decreasing. Next, increasing pH means the OH minus ions are increasing. Decreasing pH means the OH minus ions are decreasing. By these two statements, we understood that the OH minus ions concentration and pH relate directly. Children, I hope you're clear till what we discussed. And now, on the basis of this information, I'm going to ask some questions. Try to answer these questions. pH of solution A is 4 and pH of solution B is 5. Which solution contains more H plus ion? Children, try to answer this question. S. Solution A. Because H plus ion concentration and pH relate inversely. And next, pH of solution A is 10 and pH of solution B is 13. Which solution contains more OH minus ions? Okay. Solution B. Because OH minus ion concentration and pH relate directly. And next question is, pH of a solution A is 12 and pH of a solution B is 13. Which solution contains least H plus ions? Okay, solution B. Why? Increasing pH means the H plus ions are decreasing. Next, pH of a solution A is 8 and pH of a solution B is 9. Which solution contains least OH minus ions? Yes, solution A. Because decreasing pH means the OH minus ions are decreasing. Okay children, I hope you are very clear about universal indicator and pH scale. And in my next video, I'll come up with some more activities and keep watching like this only, and don't forget to subscribe the channel. Thanks for watching.